Alright, today we're going to be looking at is a hyperbola. Now, the hyperbola is the locus of all points in a plane such that the absolute value of the difference of the distances from any point in the hyperbola to the two given points in the plane, the foci is constant. Alright, so if we look at this, where the O is, that's the center, F1 and F2 are the foci, the foci. A1 and A2 are the vertices. Line segment A1 to A2 is called the transverse axis. So from this point here to this point here is called the transverse axis. The distance from the center to the focus, so the center here, to the focus is your C value. And then both the transverse axis and its perpendicular bisector are lines of symmetry of the hyperbola. This line here going up is called the conjugate axis. Okay, locus definition, meaning if you look at where the distance from any point on the hyperbola to the other one is going to be equal to 2a. Well, what is 2a? Well, remember, that's the transverse axis. It's from this vertex to this vertex here. Okay, so it's when you subtract the two, it's always going to be equal to 2a here. All right. Now we're going to look at this with the origin. The hyperbola is centered at the origin right here. The diagram shows a hyperbola centered at the origin. Your A1 to A2, remember that's your transverse axis, and the A value goes from the origin all the way to one vertex, right? And then your C value, if you remember, goes from the origin all the way to the focus. And then now your B value is the distance from the origin all the way to the top of this box here. So the way you're going to find, just like before, where you found the focus is, well, this in this case is going to be the Pythagorean theorem. It's a squared plus b squared equals c squared. Remember, the ellipse was similar to this, but it was a squared minus b squared equals c squared. So there's only a little bit difference between the formulas of the two. All right, the standard equation of a hyperbola centered at 0, 0 with the foci on the x-axis. Okay, so if I look at this and I would draw this. Okay, the equation of a hyperbola centered at 0, 0 is this here. It's x squared over a squared. And remember, A is a little bit different. It's always going to be, remember the ellipse is always the longer side, right? Well, in this case, the A value is always going to be the first one. It's always going to be the positive of the group, where the B value is always going to have the negative sign in front of it. Okay, the length of the transverse is 2A. Length of the conjugate is 2B. And the vertices are going to be A and then 0. So whatever you would have for the vertice, the distance here, that would be your A value. Okay, we'll actually do a couple here in a second. And I'll show you the equations. The equation, the isotopes are, and then this would be B over A x, and then negative B over A x. And that's your two isotopes coming across. This one is an isotope, and this one here is an isotope coming across. Alright, the standard equation of a hyperbola with the center of 0, 0, the foci at on the y-axis continued. And so if I look at this, what they're going to have is, if you notice, the A comes first, remember, because that's y, and it's always going to be the positive one. Okay, and then the transverse 2A, the conjugate 2B, etc. Let's go ahead and try some of these. I'll go ahead and go forward. All right, state the coordinates. Okay, so if I had something like this, and I'm going to be able to see that the this is going to be set at the origin, right? The center of this thing is going to be at 0, 0. Okay. Now, my A value is going to be 2 because I take the square root of 4. And so that's going to be my A value. My B value is going to be 4, right? Because I take the square root of 16. So my A value, I know, so that's the distance between the center to the vertex. So that's going to be 2. And my B value is going to be 4. And then lastly, I can figure out the C value, which is the distance from the center to one of the foci, which all I have to do is a squared plus b squared equals c squared, right? So that's going to be 4 plus 16, which equals 20. And then all I do is I take the square root of 20, and that's going to be my C value. And that's it. So that gives you your A value, your B value, and now your C value. And if you were to graph this, all you do, you start drawing the box. You know that it would have to lie on its side because the vertex is on the X. So let's go ahead and look at it. Length of the transverse axis is 2A, which is 4, which I went over earlier. The conjugate axis length would be 2b, which is 8. And then the vertices, you're going to get at 2, 0 and negative 2, 0. And then you got to do the Pythagorean theorem to get the c, which is the square root of 20. Okay, the coordinates of the foci would be, you would have to go plus and minus. So it'd be 2 square root of 5, 0, and negative 2 square root of 5, 0. And then the equations of the asymptote are 2 over 1, and then negative 2 over 1. All right, so if you actually drew this out, and you would have to look at this, and you'd see, first off, that your A value is 2, right? So all you do is you go 2 over and 2 back, so it's going to be 2 to the left, 2 to the right. And then after you do that, you do 4 up, 4 down. Okay, create a box around this. So you're going to create a box going up and then down. Okay, your asymptotes are going to go through the corners of the box you just created, right? So once you create the asymptotes, it's really easy because all you do is you draw the hyperbola that goes along the asymptote, hits the vertex, and then goes back along and just keeps skipping along the asymptote. And that's it. It's really